to the list here. So we've talked about bivariant data. We've talked about association, right? And now we're talking about the number of dots representing the pieces of data. So my next question is, does the number of items purchased have an effect on the amount of money a shopper spent? When we look at the number of items here and the total money spent, do they affect each other? Yeah. Typically, the more you buy, I mean, of course, depending on the cost of the items, but if they're all the same cost, the more you buy, the more you spend, correct? Good. So then we would say yes. The more items purchased or items bought, whoops. So now that we've determined there's a relationship between the money, the total money, and the number of items, let's look at the different types of relationships that we can have here. So a positive association. This is when two variables have a positive association when they're moving together. Meaning, the more items they bought, the more they cost. So they're going up together. They could also go down together. So like as the temperatures drop, less people are outside, right? Typically. Maybe not around here, but you get the idea. So for an example, as one variable increases, what's going to happen to the other one? It's also going to increase. Good. So it increases as well. All right, now let's talk about a negative association. Two variables that have negative association when they move in opposite directions. And if you notice, the data kind of trends downward. As opposed to the positive one, the data kind of trends upward, like from left to right. You see the difference? So an example of this could be the amount of time you spend sleeping and the amount of time you watch TV, right? If you're sleeping, you're not watching TV, right? Those go in opposite directions. So for an example, if one variable increases, the other will actually decrease. And the third type of association is when there isn't any. Look at this graph over here. It's kind of like all jumbled up all over the place, right? I would label this as random. I mean, if you notice, those points are just everywhere. So they're totally random. Even though we'll use the word random, that means no association, okay? So when we're talking about vocabulary, we use association, not random. So let's look down here. At the bottom, let's decide if there's no if it's positive, negative, or no association. So the hours a person studies and the number of states they visited. So they're studying, right? Does that mean the number of states they visit is going to go up or down? Or is it random? Think about that. Somebody's studying. Does the number of states matter at all? No. So because you're telling me no, then that means we have what type of association? No association. All right, what about the hours a person studies and their grade on an exam? They study a whole bunch. What's going to happen to their grade on their exam? So they're both going together, so then we would be positive. And I'm just going to write the word positive just because, again, I write large and I do not have enough space. All right, what about the hours a person studies in their watch and the hours they watch TV? They're studying, right? So odds are good that what's going to happen to the number of hours they're watching TV? It's going to go down, right? So they're studying more so that they watch less TV. So then in this case, this would be negative. Good. Now I know some people can study and watch TV at the same time, but this is like a perfect situation, right? You're studying, no TV. All right, flip it over. We're not quite there yet. I'm going to try to go quickly through all this so that you can work on your assignment, okay? So if you notice, some of these graphs kind of group the points together, right? If they're grouped together and around what we would call a trend line or a straight line, this is what we call linear. Ooh. Now, if they're really, really tight around that straight line, or just together in general, this would be an association that is strong. And what do you think it's going to be called when they're kind of loosey-goosey, like all around? It's either strong or it's weak. Yes. All right. Now, let's look at now these 6 graphs. We're going to look for 3 things. Strong or weak, meaning we want to see if they're bunched together, right? Positive, negative, or no association, and then whether or not they kind of make a line out of the dots, okay? So, number 1, strong or weak? Strong, yeah, for sure. Positive or negative? Or none? From left to right, is that line increasing or is it decreasing? It's increasing, so what would we say? Positive. And then would it form kind of a line as they're bunched together? Yeah, like I can draw a straight line through there. So then it would be linear. All right, for number 2. Weak. I agree, Cameron, weak. But it's weak. Positive or negative or none? Positive, yeah. It's almost similar to number 1, it's just they're a little more spread out, right? So we would say it's positive. And I think it's linear as well. Because again, I can draw a straight line and it's kind of around there, but a little bit loose around there. All right, number 3. Would you describe this as a weak or strong? I agree. Kind of bunched together. Now, is it trending upward or trending downward? Up. So then we would call it positive. Now, in this case, if I drew a straight line, would it go through those points? Not really, right? Not through the middle of them anyway. So this would be not linear. All right, for the next bunch, we're almost there. Strong or weak? Yes. Positive or negative? Linear? Yes. All right, next one, strong or weak? Yep. Positive or negative trend? Negative. Is this linear? No. Good. Y'all are already getting the hang of it. All right, last but not least, strong or weak? Weak. What about the association? None. I'm going to just write the word none because space-wise, we'd really say no association, of course. But what about it being linear? Good. So this is from graphs. We're able to identify all of those things. Now let's look at some situations where we have some real world stuff and we're going to decide the type of association. I'm not going to worry about the explanation piece. We're just going to describe it. So we're talking about a person's height and their shoe size. So they're getting taller. What about their shoe size? Is it getting smaller? Is it staying the same? Is it also growing? Yes. So what would we call that? Positive. Yes. All right, what about the number of letters in a person's name and their IQ? Does a person's IQ depend on the number of letters in their name? No, because they could be Joe, like J-O, and then they can be like, also like them, like some really, really like long name, right? So then this would be what kind of association? All right, no association. All right, what about the number of absences a student has and their GPA? Yep. Because the more absences they have, the likelihood of their grade dropping is good, right? I mean, like, that's what's going to happen. Questions so far? We're almost there. Let's do these last few really quickly. Looking at this first graph, tell me what kind of association we have. Negative. Let's label it negative. All right, for number 9, the moon in the middle. Positive. And then the last one, none. Okay. So let's start with the negative. We're looking for one of the situations that has them going in opposite directions, right? One's going up, one's going down. So a temperature outside and the total gallons of gas sold at a gas station. Would that be negative? Temperature outside is going up and the number of gallons of gas. Does the number of gallons of gas affect the temperature or vice versa? No. So that one's actually what kind of association? None. So then this one would have to be A over here, right? What about the size of a home and the cost of the monthly utilities? The bigger the house, the higher the utilities, right? So what kind of association is that? Positive. So we're looking here. And then by process of elimination, C, which would be the altitude of a hiker and the oxygen level. So the higher they get, the oxygen goes down.